And today we are going to talk about how we are using and can use self-service analytics for data democratization and speed up innovation in incubators like where we are. I think we all know that what self-service analytics is, but just to refresh, it is about providing end users with the platform, the tools, and access to data seamlessly so they can experiment, innovate, fail fast, and speed to market is much faster without the intervention of technology teams, which, as we know, in traditional IT sometimes delays and goes with certain life cycles for good reasons. But we don't want to be in the middle of innovation cycles delaying stuff. So that's why we want to provide this self-service analytics to end users to democratize data, to democratize innovation, speed up where we can across the system. And that's where I think our overall data and innovation focus in today's world is going towards. Most of the companies are very interested to mature their processes. 97% are saying that deploying and operationalizing machine learning and at scale, at speed is their key goal. But unfortunately, most of them are not there yet, and we are all marching along together. So the idea is how we can drive competitive advantage by citizen analytics. And as I was mentioning, if we can have data, of course, with the proper tools and proper governance at the hand of the innovators faster and give them that experimentation capability, we can innovate at scale and we can operationalize the entire cycle in a way that it's automated and it's fast. So if someone comes in, likes the data, wants to build an algorithm, builds it quickly, if it works right away or whenever, great, let's put it to production. If not, fail fast, learn, and move on. That's the main concept. Now, at Mass General, we started our next generation data journey on cloud using big data advanced analytics capabilities, which I'm leading with the data lake. And this is where, just to refresh, where our overall data strategy came and how we are moving ahead with self-service analytics. So this is where we are bringing all our data, structured, unstructured, across the board on the cloud, on ADLS in one place, and then making that the single version of truth. As we know, that is very important in our data journey, analytics journey, and building out all types of use cases, personas around it, building the data warehouse, building real-time applications, building data as a service, bulk extracts when we need them, and building various predictive analytics applications out of it, and data as a service, as I was mentioning. And it's highly scalable, unlimited compute almost, thanks to the cloud and storage, thanks to the cloud technologies, and enabling advanced big data analytics, algorithm driven various application development capabilities, and operationalizing it with DevOps, MLOps quickly and fast. And then we are deploying this self-service around the lake. So you can think of, we have this huge lake in the middle, and then we have these mini ponds of data and self-service environments, which are the experimentation environment. It's exactly with tools and capabilities and everything, almost like the lake, but a smaller one where you can scoop up like water, scoop up the data onto your own environment. And we will also provide all the tools and gears that you'd need to work with that data. You'll have read access directly on the lake. You'll have ability to import the data and also will have pre-built connector to other data assets. And you'll have ability to bring your own data and mix and match in your own self-service environment. So all our data science teams and many of the engineering teams, we are having this type of self-service around our main data ecosystem. And we are also building out automation that from this experimentation environment, the self-service environment, how we can help automate the DevOps, the MLOps into our core data lake, core production environment. So the idea is that anyone needing to experiment will provide that self-service with all these access and tools. They will scoop the data, do their own experimentation. And when they're ready, the training is done, the validation and all those are looking great. And when they're ready, we will put them on that production MLOps path so it can quickly be deployed in production. And what it will enable and is enabling is tremendously valuable in our innovation journey. They get quick and easy access. The engineering, development, prototyping all can be done on their own without intervention of further, bureaucratic technology processes. Quick discovery and analysis can be done. And of course, experimentation, which is the key for data scientists, can happen fast. And the other thing is, in this way, all these small self-service silos, they can now also collaborate with the enterprise ecosystem. So the duplication is less. We are building model registry, we're building a data catalog with the lake. So whenever someone is working on some idea, everyone knows where and how it's happening. So if someone else has the similar idea, they can tag along and collaborate, or they can wait and not duplicate the effort. And that's how across the enterprise, across the system, we can do more and at speed. And this is what enables fail fast that I was saying, speed to market and all those good things. Now, self-service is across the system, as I was saying, and across various personas. And we have identified some key personas based on their data consumption, data experimentation needs. And the three types of personas we have identified are what you're seeing on the screen. First is data engineering. So we have our centralized data ecosystem, centralized engineering, and various types of work. But we have more than 16 hospital sites. We have our partners, the research that goes tremendously on innovation, our clinical data science groups, and our partners with Harvard Medical School, partnership with Harvard Medical School. And we don't want, again, to be the roadblock or through bureaucratic process. So each of them have their various analyst teams, AI/ML driven data science teams, data engineering teams. So the data engineering team for each of those, they do a lot of their own data massaging stuff, but based on the single version of truth coming from the data lake. And that's one persona we target, who would focus more on building something for data manipulation or data movement quickly. And again, once they're comfortable, then we'll productionalize it. Operational analysts, it can be the power users from ad hoc analysts to the executives who likes to see and slice and dice on their own. Again, the self-service whole stack can enable them to do it quickly from their desktop instead of going through IT requests all the time. And of course, again, the IT centralized ones would be always needed, always there for more production grade, enterprise grade, repetitive, robust production support needed type of analytics and applications. But these are more for quick individual group or individual level analytics, where we would see the most usage, and innovation level, of course. And then the last one, which is probably the most popular one, is for the data scientists. So here, the data scientists will have their place for experimentation. They'll have Azure ML and other various ML focused tools and capabilities, and to discover deeper insights, again, build some model, train it, validate it, and when it's ready, put it on the MLOps path for production deployment. All of these can go through the production deployment through DevOps and MLOps, or a combination of those. But these are the key personas that all those mini ponds that you looked at in the previous slide would then be carved towards based on who are the user group, who are the customers. And a quick look at it, I won't go into details, but how we are organizing it, what our architecture and tech stack generally looks like on Azure Cloud for the lake, and then the mini size self-service would be a replica of this with a smaller subset of this. based on the user persona. And speaking of the subset, what we have done and are looking at that each of the self-service analytics environment will have a stack of technology and stack of capabilities that I mentioned earlier. And we have identified these five key categories where we have variety of technologies that are available and that will come with the package. So starting from data engineering, where we are putting in more Azure specific ADF, event hubs, and whatnot, but you can also bring or have available SSIS, Informatica, or Azure Databricks. Essentially, there are standard enterprise tools, but there are also bring your own tool concept. Again, the idea is not to limit. We want to standardize, but more to provide that flexibility for innovation. And we'll come to the standardization. It is more applicable when through the innovation to production cycle, we are ready for that. And that's when our enterprise governance, our enterprise security, enterprise standardization, all those will come in, we'll do the validation and then start to put it to production. Going back, so the data engineering set of tools, then we'll have the storage as per their need. Mostly it's Azure Data Lake storage because that's where our ecosystem right now is. We'll have various self-serve management tools where user groups or the innovators can manipulate data on their own. The more sophisticated ones can use Snowflake or Databricks, and the general business analysts can use Tableau Prep. And in the past, we also have worked with Alteryx. And again, bring your own tool if none of these work for you. Then the analytics layer, we have the Spark engines, the Python, and Azure ML is a big one that comes with a lot of good packages that are ready to deploy, and also AutoML, as you all know, is available through that. And finally, the visualization. Right now, we have Tableau and Azure Data and Power BI, actually another one. But again, these are the standard tools. Will come as soon as we carve out an environment as a self-service, which is also driven by ARM templates and is quickly and easily deployable and comes with specific connectors and data set and tools. And then you can pick and choose which set of tools you're going to use, or you're going to bring your own tool or bring your own data. Tremendous flexibility, but at the same time, governance and oversight is there. We're going to monitor who uses what data because all our data is sensitive for the most part. And we'll also provision the data with the proper security, proper masking, encryption, all those included, and no one can move the data out of the ecosystem. So from a data protection side, we are pretty well covered. We want to make sure that happens. But within the ecosystem, this is how everyone will have their own environment and the flexibility to work with. And again, a little more detail on how we work through that. And as you can imagine, given the time, I won't go too much into the details. This is one example how specifically we are building it for the data science self-service environments for one of the personas. And this is kind of how the goals and what are the key capabilities we're looking at. And again, with the right tool, import, export of data and libraries and all those available, security governance, collaboration, sharing, model dictionary, data dictionary governance, all those are key part of this environment and enablement. So they can function appropriately, as well as we can have a proper process around it. So obviously the key benefits are, again, that everyone gets to experiment at the tip of their finger with the data and the right tool quickly, fail fast and learn. There's no almost zero or reduced dependency on technology teams, so it's fast. And it empowers the users with the flexibility, and yet empowers also collaboration across because of the visibility, because of the handshakes that are now automated. And overall, speed to market and drives the data-driven culture and data democratization. This is tremendously powerful, especially in data-rich and data-focused organization like ours, where innovation can happen anywhere and everywhere, from the user group to specialized teams, because everyone has ideas while working with data that how the next innovation can happen in operational area, in diagnostic area, or in treatment area. And they can have that environment quickly to experiment with their ideas. But of course, it comes with certain risk, which we want to mitigate with proper process and proper governance. We want to make sure that the work doesn't become too siloed or too independent that nobody knows and it has its own life into production and then gets into trouble. We want to make sure that there's enough data literacy and training so everyone can be productive and understanding. And we want to make sure there's more collaboration than competition. That can also happen, but which can actually defeat the purpose, because the purpose is to collaborate, innovate faster, and for the greater good. And the other, of course, we want to keep an eye on if there are too much that, too much duplication and too much effort going on with not a lot of results. So you want to build those metrics, those processes appropriately. And most importantly, you want to have that governance around this, how you're going to carve out this environment, what the provisioning is going to happen, who's going to have access to what, and how you're going to monitor all those. So I think we are close to time.
Yes, please. Yeah, I have a question. If we can have one question, if you allow.
Sure.
One question. So Giorgio Gatti from Bohringer in Gelheim. Giorgio, you have the microphone with the questions, please. Go ahead. Giorgio, can you use your microphone? Yes.
Yeah, sure. Thank you. Thank you for that. So my question is about the governance. I think you already touched very briefly the topic, but what is the governance you put in place in order to ensure that you're not derailing in terms of compliance and also in terms of architecture? And connected to that, what is the role of IT versus business? So is IT only taking care of the platform? Thank you.
Yeah, excellent question. So again, the idea is to democratize, but the role of IT is twofold, like my organization, what we are playing today. One is to build out the larger platform, the larger data enablement, managing the centralized platforms, and building out these type of capabilities and making sure we provide the right service to keep them up and running, keep them available. And second is also we collaborate. So we also have innovation teams who work on these, on more production grade stuff and quickly. So our role in innovation, our participation in building out application and building out, algorithm or model driven applications does not go away. It only expands. Now we are also enabling others to do similar without our intervention, but the governance comes in two ways. One is they may ask us to collaborate with them to do that, and we participate and work on it together. Or it may be that we don't, because we cannot scale up, if you think about it, centralized IT, unlimited fashion. Everyone has budget and people constraint. So in that case, we will let them innovate, let them do what they do best. And when they are ready, we put a handshake, help them in productionalization, but also do the validation, the quality check, or overall standardization of certain things. So it's more about scaling up, scaling out, and we do the centralized, more production grade and highly visible, highly sensitive stuff. And then for others, which can also be highly valuable, highly sensitive, let them do theirs and then collaborate to bring it to more production grade, more high quality standard.
Yeah.
Does that answer your question?
Thanks a lot. I hope all was fine with the answer. Obviously, thanks a lot. Just I have one more question, and I would like to ask Jeremy and Susanna to wait 2-3 minutes till I finish this question. Marcus Crunch from Outrix has the question. Marcus, you have the microphone to ask, please.
Thank you very much for this very interesting presentation. My question is, self-service analytics means for me mainly an end-user accessible analytics. So people like business analysts, sales analysts, HR analysts, finance analysts, tax analysts. And when I look to your environment, when you're using Spark, Python, Azure, machine learning, this requires usually a lot of coding. Do you experience that these people are willing to code and that they're able to code?
Excellent question, Marcus. And actually that gives me the opportunity to clarify. You're absolutely right. The concept of self-service started with the end users who doesn't have the skills but wants to play with analytics, wants to see the dashboard. So that is one of the personas, if you remember, on my slide deck, which was the operational analyst persona that you mentioned. But then what we are seeing is now everyone is more and more data savvy, and everyone is more and more ready to contribute. And especially in large organizations, there are various data science teams who are ready to contribute. So for them, we are enabling this Python, we are enabling this Azure ML and more advanced tools, Databricks, more advanced tools. So it depends on the personas. So what you mentioned, that persona obviously is there, and for them, will most likely go with lighter and more user-friendly tech stack. But for heavy-duty personas like data scientists, number 3, or data engineer, we will most likely look at more heavy-duty and advanced technologies.
Thanks a lot. Yeah, I hope, Marcus, it helped you as well. One last question was from Jack Lamka from SD. It looks like you have a very complex data infrastructure. Maybe simplifying it would avoid the need for self-service system for technical users. What do you think about it?
Yeah, excellent question. Actually, it is from an overall architecture perspective, much simpler and consolidated. I should have shown you the architecture a little more elaborately. The complexity might be looking more because of the more, I would say, larger set of capabilities that we are enabling through the cloud technologies. That's why we are using almost 12, 15 technologies, because we are not only doing traditional data warehousing and data science or ML activities, we are doing real-time analytics. We are building or planning to build various types of APIs, file extracts, all throughout one. So I would argue that it is not actually a complex, it's much simplified than having 16, 20 data warehouses across various siloed capabilities. The goal is to bring them together, where the complexity, and I agree with you on that, is that because we are providing such variety of capabilities, from data warehousing to application to ML-driven activities to real-time analytics, it appears to be a lot of technologies in one place. But generally, it is much more simpler. That's one part. And second is, yes, we do provide a lot of access. There will be production grade access for many thousands of users. But for experimentation, you cannot let everyone to play on your production grade environment. That'll do two things. It can either harm your other users and applications which you don't want, or it'll bring more bureaucracy if you want to govern them too tight. So the idea is to bring the flexibility, provide them faster path on their own, and then